What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at Cpctc, which is another way to say corresponding parts of congruent triangles, and how we can prove relationships in geometric figures and how those triangles can be congruent. So what does Cpctc stand for? It stands for what your title of your notes is, corresponding parts of congruent triangles. Okay, and that means they are congruent. So, when do you use it? When you are asked to prove parts are congruent, first you have to prove that triangles are congruent. Okay, so what we're going to do is we're going to see quite a bit of proofs today in this lesson. This is usually when you would use it. When you're trying to prove specific parts that are congruent that might not be been given to you, and you can prove that the triangle is congruent. So because the triangle is congruent, then all corresponding parts would be congruent as well. So let's go ahead and try example 1. We have given AB is congruent to AD and BC is congruent to CD. So what I like to do first is I like to maybe give some tick marks here so my brain can pay attention to what I know is correct. So AB is congruent to AD, and then BC is congruent to CD. From this, you can probably go ahead and say, you probably know what next step we can use to prove that this triangle is congruent and the reasoning as to why that is. But our last reason is going to be the corresponding parts of congruent triangles are congruent. So let's go and start with our two givens. AB is congruent to AD, and BC is congruent to CD. So both of these are going to be our given reasons. Next, step 3, I'm going to go ahead and say AC is congruent to AC using the reflexive property. And if you want to, you can also give those some tick marks, okay? Right now, I'm showing that those triangles are congruent because of side, side, side. So we're going to say triangle A, B, C is congruent to triangle A, D, C using the side, side, side congruence theorem. And because these triangles are congruent, then I can prove that angle BCA is congruent to angle DCA using corresponding parts of congruent triangles are all congruent, or Cpctc. Let's see if we can try the next one, and if you want to, pause the video here so you can try this one on your own. If not, go ahead and click play to see how it's gone, and you can follow along with me there. All right, as always, let's go ahead and write down our givens. First two lines, PS is parallel to QR, and angle QPS is congruent to angle SRQ. So let's go ahead and label a few things. I'm going to put my arrows for PS and QR to show that they are parallel, and QPS is congruent to SRQ. Okay, so given here and given here. Okay, now when we get into parallel lines, yes, there's a lot of different options we can use to show what's equivalent and what is not. So keep in mind, if you might have tried this one a little bit differently than me, but you should still be able to prove that those two triangles are congruent. I went with angle PQS and angle RSQ, and I said that those are congruent. So angle PQS is congruent to angle RSQ because of alternate interior angles. Alternate interior can be proved with my parallel lines, okay? The next thing I can come out and say is that SQ is congruent to SQ using the reflexive. Okay, so right now I have angle, angle, side. So because I have angle, angle, side, then I can say that those two triangles are congruent. So I started with triangle SPQ is congruent to, be careful of your congruent statement here, QRS triangle, using the side, side, side congruence theorem. So now I can then follow up and say PQ, which I knew nothing about, and RS are congruent using Cpctc. Okay, let's try our third example. This one, we want x is the we're given x is the midpoint of both lines WY and VZ. I want to know, how can I prove that XWV is congruent to angle XYZ? Again, if you want to, pause the video here. If you want to try it by yourself, if you're ready to check it with me, let's keep going. So I'm going to go ahead and write down my given. X is midpoint of WY and VZ. So we'll say that's our given. And then I'm going to break down two statements for midpoint. I'm going to say WX is congruent to XY using definition of midpoint. And then Vx is congruent to XZ, also definition of midpoint. So what I'm going to do is I'm going to also plot those markings, or write those markings on here. So Wx congruent to XY, so those are my two sides that match. And then Vx matches XZ, those are my other two sides. When I'm thinking of all the reasonings as to proofs and why I do that, if I have two sides, I can just include look for an included angle. So I'm going to see if I can prove these angles congruent, and I can using vertical angles. So angle WXV is congruent to angle YXZ because vertical angles are congruent. Now I can say that both of those triangles are congruent. So triangle WXV is congruent to triangle YXZ. Again, being careful of my congruence statement using side, angle, side congruence theorem. And because my triangles are congruent, that means angle XWV is congruent to angle XYZ using corresponding parts of congruent triangles are congruent. Okay. Last example, if you haven't tried one by yourself, this is your chance. Go ahead and pause the video here, and when you're ready to check it, go ahead and click play. All right, we're going to go and write down our two givens on our first two lines. BC is parallel to EF, and D is the midpoint of BF. Okay. I'm going to go ahead and label BC and EF with parallel lines, and D is the midpoint of BF, so that means BD and DF should be congruent. So let's go ahead and make that be statement number 3. BD is congruent to DF using definition of midpoint. Okay. The next thing I see, I'm seeing some vertical angles. So I'm going to say angle BDC is congruent to angle FDC, so that vertical angles are congruent. Okay, so again here, these two. And because I have parallel lines, I can do a few different things. So this is where your proof might be a little bit different than mine. You can say that angle DEF is congruent to angle DCB. using alternate interior angles. That is the one that I used. That does not mean that you could not have used angle EFD and angle CBD, okay, because those would still be alternate interior as well. But I'm going to stick with angle DEF is congruent to angle DCB using the alternate interior angles congruence theorem. Okay. Because I use that, now I am seeing angle, angle, side. But if you used these two angles, then you would do angle, side, angle. Still correct, just a different route that you could have taken. So triangle DFE is congruent to triangle DBC using angle, angle, side, congruence theorem. And because my triangles are congruent, now I can say that ED is congruent to DC using my corresponding parts of congruent triangles are congruent. Okay, that is the end of our lesson. So hopefully that helps you understand proofs now using Cpctc. Really, it is just one extra step. So a lot of you felt confident with, like, for instance, steps 1 through 6, how to prove triangles congruent. Now we're just using proving triangles congruent, adding on one more thing. Thanks for tuning in, and we'll catch you next time. Have a great day.